Theorem number 1.3. Before going to discuss about 1.3, let us see rational numbers and its forms. Here I gave some rational numbers 7 by 25 and 51 by 64 and 80 by 100 and so on. Okay. First we would like to take very simple rational numbers like 3 by 4 and 4 by 4. These two are rational numbers, right? 3 divides how much? 4. 3 divides 4. 3 divided by 4. Then 3 will not go. Then we take point, 0 point. You can keep 0 here. Everybody knows. How many times? 7 ja 28. 2 remainder. You can keep 0. 5. Very simple. 3.4. 3 by 4 is nothing but 0.75. It's clear, Amma? So every rational number can be expressed as a decimal form. 3 by 5 is a rational number. It is a fraction form. You can write it down into 0.275. That is nothing but decimal expansion. Suppose if you take 4 divides 3. 3 1 ja 3. 1. Keep 0 and 3 3s are 9. 1 again keep 0. So 0.333 and so on. Sorry, 1.33 and so on. By observing these two fractions, no doubt at all, every fraction in the form of either terminating decimal, non-terminating repeating decimal are also called recurring decimal. Anyhow, every rational number in the form of terminating decimal or non-terminating repeating decimal. Here when we see the fraction, we cannot say either in the form of terminating decimal nor non-terminating repeating decimal. By this theorem, you can say that directly without actual division, you can say which is terminating decimal, which are non-terminating decimal. By observing the fractions in its denominator. Suppose if you take 3 by 4, 3 by 4, you can write 3 by 2 square. If you observe this fraction, 7 by 5 square, it is also divisible by 7 and gives the terminating decimal. Let us see how to do that one also. 7 divided with 25. Keep 0 and put a point and keep 0 here. 2 times 50. Remainder 20. Again 8 ja 200. Remainder 0. See this one also. I told you clearly. It is a terminating decimal. When we observe some 3 by 7. 3 by 7. Again it is not terminating repeating decimal. Again I would like to show it. 3 divides 7 will not go in this one. Keep 0 point and keep 0 here. 7 4 ja 28. Again 2 ja keep remainder. 7 2 ja 14. Okay, again 6. Tell me how many times? 0. 7 7 ja 49. 7 8 ja 56. Again 4 remainder. 0. 7 5 ja 35. Again remainder how much? How much, Amma? 5. Keep 0 again. Again tell me 7 7 ja
49.
49. Okay, remainder how much? 1. Okay. Next, keep 0. Again 1. 7 1 ja 7. Again how much, Nana? 3. Again keep 0. 7 4 ja. Again 4. Amma? Again. See here. Up to here. Repeated again. See, 7 4 ja again 28. That means it came to again 30. That means what is the recurring part here? 4 2 8 5 7 1 is the recurring part. Again it will repeat it. After the 4 after you will get 2, again 8, again 5, again 7, again 1. So it is repeating like that. So when we observe the denominators of the rational numbers, if they are in the form of some 5 power something or 2 power something or their product. Or their product means you can take some 7 by, I would like to write only take 3 by 10 I would like to take. 3 divides with 10 again. How many times? 0 point, keep 0. How many times? 3 times. Again it is a what? Terminating decimal. By observing all the rational numbers with its denominators, they are in the form of 5 power something, or denominator are in the form of 2 power something, or their product maybe 5 into 2 can we write like this? 2 by the 10 only. That means its power here 1, its power is 1. Isn't it or not? So the powers are maybe indifferent. Maybe different means we can take some 3 by 5 square into 2. How much? This is equals to 5 square means how much? 25, 25. 2s are 50. Suppose if you take 50 here. 50. So 3 divides 50 right now. So how many times? 0 point. Keep 0 here. 1 time. No. 2 zeros you have to take, right? Yes. How many times? 6 times I think so. 6 is 30. 300. Again you got 0 or not? That means 3 by we can write 5 square into 3, right? Isn't it or not? So if any number or any fraction that in its denominator in the form of 5 power something, I done wrong here.
5 square into 2.
5 square into 2. Okay, sorry. 5 square into 2. So 5 square into 2. 5 square means 25. 25 2s are 50. Okay, sorry. Okay, anyhow, every fraction or a rational number in its denominator. In a fraction, the denominator in the form of some 5 square or 5 power something, whatever it may be, you can take raise the power 100 also. It should be a terminating decimal. So if you power 3 square by 3 by 2 square I take in here, you can take 3 by 2 power 100 also. It should be terminate. Terminate means somewhere it will be stop. The fraction will be stop. When we divide 1 by 1 by another, we get all our decimal fractions. They should be terminate when its denominator in the form of 5 power n or 2 power n or their product, suppose 5 power m into 2 power n also. Their product means here see 5 square into 2. This is how much? 50. When 3 divides with 50, we are getting 0.06. It is also terminating decimal. The theorem says the same thing. Let x be a rational number. Whatever it may be, x be a rational number. Whose decimal expansion? Whose decimal expansion? This is the decimal expansion. This is the decimal expansion. And this is also decimal expansion. Terminates. The decimal expansion terminates means it will be stopped somewhere. X can be expressed in the form of p by q. See here, P by Q. Every fraction in the form of P by Q. Where P and Q are the co-primes. Co-primes means they don't have common factors. See here in here, there is no common factor. See here and here, there is no common factor. See here and here, there is no common factor. See this one, what is the next one? 7 by something I taken. 7 by 3 I taken, right? 3 by 7. 3 by 7 I taken, right? Here. Here also there is no common factor. Those are called co-primes. So where P comma Q are the co-primes. And prime factorization of Q. Prime factorization of Q means denominator. P by Q in which Q is a what? Denominator. Is in the form of 2 power m into 5 power m. I already explained. 5 power m into 2 power m. Where n and m are the positive integers. Positive integers means what? 2 is a positive integer or not? Where we retain some. Here, 2 square. 2 is a what? Positive integer. So, very simple, keep in mind, if any fraction in its denominator, if you can write in the form of 5 power m into 2 power n, then it is should be terminated. Otherwise, non-terminating, repeating this one. That is also called non-terminating, recurring decimal. Very good. It's clear on. So if you take any fraction, those fractions are called what? Rational numbers. Every rational number can be expressed in two kinds. One is in the form of terminating. The second one is in the form of non-terminating. We can say directly it is terminating or non-terminating, depends upon its denominator. So if denominator in the form of 2 power m into 5 power n, then we can say it is a terminating decimal. Otherwise it is a non-terminating repeating decimal. That's all. Understand?